This is the Earth Science Classroom. Welcome. This is the topographic maps video looking at contour lines, the part 1. And in this video we're going to discuss what a contour line is, how it represents a landscape and shows the relief or terrain of that particular landscape or the map it's showing, and look at the rules that we work with contour lines and how to decipher the map properly and give us the most information we can out of this two-dimensional image, which can be interpreted as a three-dimensional terrain. So what is a contour line? A contour line, well, let's look at the word origin. So it derives its name from Italian, and that word was contorno, which basically means to draw a line. And we know that con is with or together, and torno is looking at an outline or a single line. So you basically draw a line, and in this case you're drawing a line on a two-dimensional map, and what you're doing is you are going to connect points on the map that have the same elevation. Now, elevation is the height above sea level. Now, we generally use 0 feet or 0 meters for sea level, but we know that in the advanced levels, we know the oceans are constantly in motion and not always at 0 feet because of tides and waves and currents. But this is a general term here, and what we're looking at is the land we know goes up. So if I draw a little ocean here, we know that the land is going to go, once it gets to the beach and the beach face, it's going to rise up above the ocean to wherever mountains is. So looking at Everest being 29,029 feet, that's currently the top or the highest elevation on the planet, and that's this distance in feet above sea level. So I kept sea level, just imagine it going through the ground, so Everest would be 29,000 feet above that point where the ocean would be. So it's just vertical distance. It's nothing to do with actual horizontal distance, because that can fluctuate. So looking at elevation and height, and we measure it in feet or meters. So if I had, let's say I had just an area, and I had these points, and these x's represent different elevations on this surface. Let's say I use 10 elevation. 10 could be feet or it could be meters. It doesn't matter. Let's do 10 right there. Okay, now once we have these points listed on the map, we can then join them up with a fluid flowing line, and we can join these 10s up right that. Now, a contour line have various rules, but before that, I'm going to show you how you draw them. So when I've drawn this red line, representing a line that connects all the 10s, elevation 10s, it's saying that anywhere along this red line, this contour line that I've just drawn, is going to be elevation 10. It could be 10 feet or 10 meters. So even though I have the original 4 locations that have the same elevation, anywhere along this red line, the contour line tells us that it has to be 10, because the contour line only goes where the elevation is 10 feet. It doesn't deviate or move or change elevation. It is always set at 10. So anywhere along this line is 10. If I stand here or there, it's going to be 10 elevation. Okay? So now I've added 3 more contour lines. So right here, this is the 25 contour line right here. we have the 20 contour line there, and we have the 5 contour line here. Now I've drawn them kind of accurately according to where the 10 contour line is. So let's say I put a little compass right here for north. So if I am going to stand on the elevation 10 right there, and I'm looking north, I will be looking towards the 5 contour line, this green one, which says that anywhere along this green line, it's going to be 5 elevation, 5 feet or 5 meters. Now I know that that is a lower number, so I'm going to be looking downhill, because currently at elevation 10, I am a higher elevation than 5. So if I'm looking north, according to the compass right here, I'll be looking downhill to a lower elevation, and it's shown here, which is where 5 is. Now, if I was going to stand here, it's hard to tell what elevation I'm at exactly, but I know there's a range. So I am between 5 and 10 elevation, because I'm standing in between these 2 contour lines, and that gives me an idea of my elevation. Not exactly, but there's a range. So if I'm going to look also to the south, okay, I'll be looking uphill, because I'm looking towards 2 contour lines, 120 and 125, and those 2 are both higher up than the 10. So I'm looking uphill. Now there's one I missed out, if you didn't notice that, and I'll draw that in black, is actually going to be this contour line, to keep the same scale and the same rules for this map. And this would be a 15 elevation contour map. Why? Because as you see, there is a contour interval of 5. What is a contour interval? It is the change in elevation between each contour line. As you see, one contour line is 5, next is 10, then 15, then 20, 25. So it goes up by 5s. The contour interval is consistent or stays the same for that exact contour or topographic map. That way it's easier to figure out, because I've drawn a very basic map, but if you look to the left here, there's another contour map, like an actual contour map of a location. You'll see that only some of these contour lines have numbers, and the other ones, the ones that don't have numbers, okay, you need to have a set contour interval so you can figure out what each elevation is for each contour line. So in terms of what the contour line does, contour line takes a 2-dimensional image, flat projection, and when you add the contour lines in with the various details and the elevations, you can transfer or interpret that same 2-dimensional picture into a 3-dimensional graphic or 3-dimensional representation of that area, so you can see where the high points are and the low points are, so you can actually see what's called the relief. The relief is the elevation, the changes in landscape and terrain of the area. So you can see where the high relief is, which is the higher elevations, the mountains. You can see where there's valleys. You can see where, if you're at a certain location looking downhill or uphill, you can see the low areas, going towards fluvial systems or lakes or oceans or seas. You can see also, and when it rains on this area, you can also have an idea of where the rain's going to flow, where you'd have rivers, where you perhaps have groundwater or streams, where you'd have various levels of erosion, or if you're an engineer, how and where to build different things like roads and railways and utility lines and houses and parking lots, because you need to know the shape or the relief of the land, and the contour lines show you exactly that. So when we're discussing contour lines, we're discussing the rules, right? The simplified, consistent procedures that you can look at when you look at any contour map, right? So the first 5 are listed here. So as I discussed earlier, the contour line itself is a line that connects equal points of elevation or height on the Earth's surface on the map. Okay, so equal elevation. All right, and then it's going to separate uphill from downhill, so you can see where the different terrain is, and this refers to relief, right? The shape of the land. You can see where the flat areas are and the plateaus, right? Maybe a mesa, maybe a long valley. Again, you can denote this from geomorphology and what would create that kind of area versus the uphill and downhill areas. The ridge would be more of the uphill, the higher relief, and the valley would be more of the low relief environment. These lines do not cross or intersect, right? So the contour lines can be very close together, like this. But you'll never see a contour line do this and go across and exist in one. Why? Because remember, the contour line, okay, denotes a certain elevation, a discrete elevation in feet or meters. If you have 2 crossing over, you're saying that in these locations, you have, on the same location, you have two different elevations, which is physically impossible. If you are on a certain location on the Earth, you are at a certain location. You're not going to be at 2 different locations at the same time on the same location. Then we have index lines. Index lines right here are bolder. They are contour lines used for reference. Now, let's take this map on the left-hand side. You've got loads and loads of contour lines on this map. The green shading denotes vegetation, and the lack of green is probably just bare rock. So what you have is, you have certain contour lines, like here, this is where it says 900, okay, or 700, or 600 right there, or 1100 right there. So these index lines, they have the elevation that's at the number actually on the line, whereas the other lines, like this one right here, or this one right here, they don't have any numbers. So these index lines are used, they're bolder, more pronounced, easier to see, and they are every 5th contour line. And they have the number, they have the elevation. So we can use this to calculate the contour interval of our map, okay? So here we have on the left-hand side a very basic contour map, right? So this one right here is going to be our index line. I'll make it a bit bolder, right? There we go. It's a bit bolder. There's and it's elevation 100. Then we have, then we count 1, 2, 3, 4, 5. The 5th one, remember the 5th contour line, it's going to be another indexed contour line. This one right here. Make it a bit bolder. There we go. So this one is going to be 200 in elevation. Now, how do we find out? The interval is the change of elevation between each contour line. Now, these lines haven't got any number on them, so we've got to figure it out. So we do, what's the difference between 200 and 100? So you just do basic subtraction, so you equals 100. There are 5 lines in between, so you do 100 divided by 5. What's that? Equals 20. So our contour interval for this particular diagram is 20. So we can actually put the numbers in. If you want, you can put in 120, 140, 160, 180, and 180 plus 20 is 200. So that works out. And you can do that with any values, but the contour elevation, the elevation will be very like whole numbers and large, easy use numbers. You never find a elevation on contour map or contour line with elevation 87.5. No, it'll be either 50, or it'll be like in 20s or in hundreds or thousands, depending on the scale of the location you're looking at. That's the most appropriate contour line to use. In a very flat area, maybe it's in 20s, but in the Himalayas, you might want to go up by thousands. Okay, so it depends on the location, but that's how you figure out the contour interval. So we're back to our more complicated, more complex real-life contour map on the left here. If we take this section right here, where you've got the index lines of 700 and 600. Okay, so you've got to figure out how many lines are between them. So if we follow this darker 600 around to here, we can then count. So starting from 600, you get 1, you get 2, you get 3, you get 4 index line contour lines, and the 5th one is 700. So again, we've got 5 contour lines between 600 and 700. So all we do is that difference is 100 divided by 5 again equals 20. So this line right here, if I was going to stand right here on this contour line, I could tell you using the contour interval, which is 20, or CI, which is 20, I can tell you this is 620, 640, 660. So I would be saying that 660 elevation. Now I'm assuming that that is feet on this map. So using the interval, you can figure out which contour lines are what elevation, and you can also see where the relief is, the high points and low points, using the index lines. So the last rule on this video is the horizontal or lateral difference. So the spatial differences, right? So now we have this map. We see areas where the contour lines are spaced out, like here, and we have areas along this map where the contour lines, obviously, you know, in this area right here, contour lines are very close together. So if they are close together, like in this area, right, that denotes a steep gradient. Or a steep slope, where the surface is at an angle. It's not flat. Okay? And this area right here, this would denote that it is a gentle slope, or even if it's very far apart, contour lines, then it's actually flat area. However, the Earth doesn't really have a great deal of flat space. Now there is some, but there's always going to be some sort of gradient, some sort of slope, some sort of hill or downhill aspect to our Earth's surface, and that's where contour lines can show us where those are and the degree of how steep that gradient or slope is. And again, that can tell us a lot about the relief and the terrain and the landscape, and also look into geomorphology and even the history of the area and how this area became to be a certain relief or elevation across the map. So in video 2, we're going to get on to different rules that add on to more rules. The first 5 are listed here, and then we'll get on to more on gradient, how to calculate gradient, how to use it in the classroom, and I'll see you in video 2. Thanks.